Well, hello, welcome back. This is part three of our energy unit. And in the first two parts, I described for you a way to break down all the different forms of energy into seven different, what we call forms. And I emphasized when I did that there are some places where you'll go and they'll do like 10 different forms, and some places they'll do six. I just thought these seven are a nice way to describe everything, and there is sometimes a little overlap. Like, for example, there's a fine line between thermal energy and chemical energy, or sound energy is actually a special type of mechanical energy. But I think for the most part, these are pretty easy to distinguish and to recognize. And you're going to need to do that today because I'm not really giving you notes, but I'm going to show you what we're going to do in our next step. And that is we're going to look at energy transformations. Now, let me break down that word for you. Transformation. So the word form is in there. And all this means is to turn from one form to another form. Okay, sometimes these are called energy conversions. We convert one form of energy into another form. And our world is filled with things that convert energy from one form to another. So we're going to look at a few examples here in this short video, and then I'm going to give you some to see if you can recognize as your little exercise for today. Okay, so listed to the right there are the seven forms as I described them. And some of you might think, wait a minute, where are the kinetic and the gravitational potential and the elastic potential? Well, all of those are wrapped into this single term here. Those are all considered mechanical energy. So any one of those, if it involves the motion of something or the location, the position that it's in, we're going to call it mechanical energy. All right. So let's look at our first example here. Hopefully you recognize this picture. This is a wind turbine. You don't see a lot of them around here where we live, but I occasionally drive from the Dayton area to Chicago, and I go through a part of Indiana where there are miles and miles of wind turbines. It's a whole farm of wind turbines. So what are those things for? What are they doing for us? Well, if we think of it from an energy transformation point of view, what they're doing is they're turning the wind into good, usable electricity. Okay, so what energy forms are those? All right, so what I've got here, and this is what we're going to do in your exercise too, is I want you to pick one or possibly two forms that you start with, and then what are you turning it into? Okay, so what do we need to run a wind turbine? Well, we need a breeze, wind. The more wind, the better. So what form of energy is that? Now, we don't need the heat. I mean, these work in the wintertime as well. We don't run them off electricity. We don't need light. What we need is a breeze. Breeze is motion, the air in motion. So that motion is mechanical energy. So we would say mechanical energy transforms into what? Well, what are we trying to make with a wind turbine? We're trying to generate electricity. So we call that electrical energy. So wind turbines, from an energy perspective, are things that convert mechanical energy into electrical energy. That's the idea. Let's look at the next one. A desk lamp. So again, just ask yourself, well, what do you need to run a desk lamp to make it work? Well, you need to plug it in, right? And what kind of electricity is that when you plug it in? That's electrical energy. Get electrons running through those wires, and they run through the little lamp, and different kinds of lamps work differently. But what are we trying to get from the desk lamp? Primarily, we're trying to get light. Now, you could argue that some desk lamps also get warm, but that's not mostly what we're trying to do with them, right? We're trying to get light. Well, where does light fall into our energy forms? Remember, electromagnetic is a long name, and it encompasses lots of different kinds of energy. The one you're most familiar with is visible light, which is what we get from the desk lamp. But there are these invisible kinds of electromagnetic waves that we have out there. In fact, we're living in a sea of them. Things like infrared and ultraviolet, X-rays and radio waves, mostly radio waves. But all of those fall into the category of electromagnetic waves or electromagnetic energy. So that's what a desk lamp does. Let's look at this one. Now, you all know this one, a moving car. What are we trying to do with a car? We're trying to get it to move, right? What do we need to get it to work? Well, in most cars, you put in some gasoline, right? So you got to start with some gasoline to get the motion out. What is gasoline? I categorize this as a fuel, and it was one of the examples I used for chemical energy. It's probably the hardest energy to recognize because it's hidden in the chemical bonds, and you don't really see it. But you know you definitely need some gasoline to make the car run. That's chemical energy. Any kind of fuel, including food, which is fuel for your body, or batteries. That was the other one that people commonly don't recognize that's chemical energy. If you have an electric car, actually it's the battery's chemical energy that does it. But either way, you start with chemical energy, and to get it to move, again, that's motion energy. That is considered the mechanical form of energy. And finally here, the sun. Now, I mentioned this when I described my energy forms on part 2. The sun is about the only one that will begin with nuclear energy. What's going on up in the sun is nuclear fusion. We've got these small atoms bashing together, and the nuclei actually form into new things. Okay, so we change the identity of the atoms, and that's actually considered a nuclear reaction. So we start with nuclear energy. What are we getting from the sun? Well, now I think there's 2 really good answers, aren't there? Think about what the sun provides for us. Now, it provides this for the whole solar system, but in Earth in particular, because this is where the people are that need it, we get both the warmth as well as the light from the sun. So I'm going to say we get both thermal, that's the warmth. It makes all the particles and everything vibrate just a little bit more. And what that indicates is that the temperature is a little higher, a little bit more thermal energy. The other is the light. And again, we just talked about light being categorized as electromagnetic energy. Okay? So everything that's around you, your own body, is an energy transformer. The fuel that you consume and then you store in your cells as chemical energy. And then you use that for all kinds of things, for the motion that you do, for all the thinking that happens in your brain. There's actually your nervous system, a little tiny bit of electricity running through there. So your body can convert that good stored chemical energy into all kinds of different forms. For the most part, I would say for people, we would call it mechanical energy because we move around a lot. But again, everything around us can be kind of analyzed from this energy transformation perspective, okay? All right, so hopefully that gives you a feel for what we're going to do here. You can start looking at things in your life a little bit differently than you usually do. We'll give a little practice for you for seeing if you can recognize some of those things around you. All right, thanks for watching.